Hello everyone, welcome to today's movie. In today's movie we're going to look at linear regression analysis, and we're going to fit a prediction interval for that regression model at a particular value of x, and we're going to use Excel. In a later movie we'll look at the use of SPSS. So what we're going to do is, if we go to the Excel solution that we have on the screen, now we know from the book that the prediction interval is given by y at minus some error, which is less than or equal to y, less than or equal to y at plus some error, where the error term is given by that equation there. Okay, now we can use Excel to solve this particular problem. So what it might say is, what a 95% prediction interval, confidence interval at a particular value of x. So what we need to do is, there's our numbers for y and x. We can calculate the slope. We can calculate the intercept of the line using the Excel function intercept, just like we did in the previous movie. We can calculate the slope of the line using the Excel function slope. Okay, so if we know that x is equal to 60, and we want that prediction interval, confidence interval, for x equal to 60, a range of values, okay, using this equation here and this equation here, then you can see that what we need is, we need to know n, the number of numbers, paired numbers. So we can use the Excel function count a from C5 to C45. And that gives us that we have 41 paired values. We want a 95% confidence interval. So in other words, the significance level is 5%, which is 0.05. The degrees of freedom for this problem is n minus 2, so it's 41 minus 2 is 39. We can then use the t.inv.2t Excel function to calculate the critical value of t, which comes out to be 2.0227. We know that the x value is 60. Okay, that's what we've input, that's what we want to know. We can calculate x bar, because if you look here, can you see you need x bar, the average x value, which is using the Excel function average from C5 to C45. Okay, right, and then once we got that, then what we can do then is we can calculate what at x equal to 60, what is the value of the line value. So we know it's the intercept plus that times 60 gives us that. So the y value at x equal to 60 is 6520.8 to 1 decimal place. Then we need to calculate, if you look here, you need to calculate the sum of x there. So the sum of x is the sum C5 to C45. You need to calculate the sum of x squared there. So that's given by sum of E5 to E45. So to calculate this, I've created an extra column called x squared. Yeah, so x squared, that one is C5 squared, give us that, C6 squared to give that, C7 squared to give that. And then what I need to do then is I need to sum all the values. I need to sum all those values there to give me the sum of x squared. Okay, then I can calculate the standard error of the estimate using the Excel function steyx, where the y values go from D5 to D45 and the x values go from C5 to C45. So the standard error of the estimate is 260.5622 to 4 decimal places, which is that number there. And then what we can do then is we can then calculate what E is. So we use this equation, put all the numbers in to calculate that the error, the 95% confidence interval error, is 564.2287 to 4 decimal places. And then all we do then is substitute that number into this equation. We know y at, so we know y at minus that gives me the lower value, which is that, and then y at plus that error term gives me the upper bound, which is that. So the 95% prediction interval for when x is equal to 60 is between 5956.5 to 7085, with the line value at 6520.8, with all the values to 1 decimal place. So that's how you fit a prediction interval for on that trend line for a particular value of x. In our case, we chose x is equal to 60, but you could have chosen any value of x. So hopefully you enjoyed that movie. In the next movie, we'll look at how do we solve exactly the same problem using SPSS. Okay, bye for now.